All right, the next model problem in this deals with elastic versus inelastic collisions. We actually did this in a section further back when we were doing grade 11 physics. The difference between an elastic and an inelastic collision is if it is elastic, then kinetic energy is conserved. And we watched a video on that with basically two what they call friction carts bouncing off of one another. If they bounce off and the kinetic energy before is the same as the kinetic energy after the collision, it's classified as an elastic collision. Now, no elastic collision is perfectly elastic. So what we're looking for is when we look at the kinetic energy before the collision versus after the collision, it should be pretty much the same. If it's pretty much the same, then you say that the collision is elastic. If it's not at all close, then you say it's inelastic. And no matter what type of collision it is, elastic or inelastic, momentum is always conserved. The momentum before the collision is always the same as the momentum after the collision. So I'm on page 514, 515 in your textbooks. Sorry. And it says you have a 0.052 kilogram golf ball. So mass of the golf ball, 0.052 grams. They actually have one more significant figure. They have this. Again, that's 3 significant figures. You never start counting until you get to the first non-zero. So that's 1, 2, 3 significant figures on that one. And it's moving east, so it's going east. And the golf ball has a velocity of 2.10 meters per second. So golf ball's rolling along at 2.1 meters per second. It suddenly collides head-on with a billiard ball. I don't know why a billiard ball is in the way, but apparently a billiard ball is in the way. And that billiard ball has a mass of 0.155 kilograms. Wait, how many 5s did they put on there? Just 2. 0.155 kilograms. Please note, this is in grams, this is in kilograms. That will be a problem we will have to deal with, right? Oh no, it was in kilograms. I lie. I didn't notice the little K there. Kilograms. Good, we won't have to deal with that then. It says it collides head-on with this billiard ball. If the golf ball rolls directly backward with a velocity of negative 1.04 meters per second, so the final velocity of the golf ball is negative 1.04 meters per second. So billiard ball is sitting here, golf ball hits the billiard ball and bounces directly backwards. It says, was the collision elastic? Was the collision elastic? So what we have to look at is what was the kinetic energy before the collision and what was the kinetic energy after the collision. Now I'm going to show you why you can't go straight to that. I'm going to try and go straight to that, and you're going to see why we can't go straight to that. So if I mistakenly said all I need to figure out is kinetic energy, because if kinetic energy before is the same as kinetic energy at the end, then I know it's elastic and I'm done. So let's just go straight to kinetic energy. So before has to equal after if kinetic energy is conserved. So what we have to do is we have to figure out what is the kinetic energy before and what is the kinetic energy afterwards. Well, before the collision, the golf ball is moving, which means it has kinetic energy, but the billiard ball's not moving, so it doesn't have kinetic energy. So before, all we have is kinetic energy of the golf ball. And if you think way back, kinetic energy is 1/2 mv squared, which sounds great. both things, though, are actually moving because the billiard ball's going off that way, the golf ball's going backwards. They're both moving. So after, you're going to have the kinetic energy of the golf ball, plus you're going to have the kinetic energy of the billiard ball. So you would need 1/2 mv squared of the golf ball plus 1/2 mv squared of the billiard ball. So let me see what I can fill in here. 1/2 mass of the golf ball is 0.052. Velocity of the billiard ball, got that, that's 2.1 squared, is equal to, now final kinetic energy of the golf ball, I can even do that because I have 1/2 mass of the golf ball, which is 0.052, and final velocity of the billiard ball is -1.04 squared, so I'm even good there. But here's where I run into a problem. When I get to the billiard ball, I have 1/2 the mass of the billiard ball, which is 0.155, but I don't have a velocity of the billiard ball. And I can't just solve for V this way because I don't know whether this was elastic or not. So I don't actually know if this is equal or not. This is just my guess. I don't actually know that they're equal. So what I have to do then is I actually have to go back so that I can figure out how fast is the billiard ball going after these two balls have collided. The only way to talk about that is to talk about momentum. And so again, I'm going to talk about momentum before the collision, and I'm going to talk about momentum after the collision. And momentum is always conserved no matter what. So that means the before momentum has to equal. I do know that that should be an equal sign. Over here, I'm not sure it should be. I'm just guessing. So if I look at momentum before the collision, I have to look at the momentum of the golf ball and the momentum of the billiard ball. So momentum is mass times velocity. So before the collision, the golf ball is 0.052, and its velocity is 2.1, plus for the billiard ball, the mass is 0.155, but the velocity is 0 because the billiard ball isn't moving before the collision. So after, the golf ball still has a mass of 0.052, but now its velocity is -0.104. Really important that you put the negative there. Plus, billiard ball, the mass is 0.155, and the velocity of the billiard ball is actually what I want to know. So now I only have one unknown in this whole thing. I can solve for it. Again, not going to spend a lot of time going over that. At this point, you should be able to isolate a variable in an equation. It's really the setting up of the equation that's the problem. It turns out it should be 1.0534. 1.0534. So now I know what to put in here for velocity squared. I'm going to put 1.0534 squared. So once I know what the final velocity is, I can put it in over here. So now what I'm going to do is I'm going to check the kinetic energy before and the kinetic energy after, and I'm going to see what numbers I get. So here's the before. So I'm going to do 2.1 squared times 0.052 times 0.5, and that gives me 0.11466 joules, because we're talking energy, we're talking kinetic energy. So this is how much kinetic energy there was before the collision. After the collision is all of this. So I'm going to do 1.04 squared times 0.052 times 1/2 plus, I'm going to put this all in brackets, 1.0534 squared times 0.155 times 0.5, and I'm going to get 0.114 now it's 0.1141, but remember I said it has to be pretty much equal. Those are pretty much equal. I mean, they're the same all the way to the thousandths place. So I would label this as yes, it was an elastic collision. So if it's elastic, kinetic energy is conserved. I tried to go straight to the kinetic energy, but I didn't have enough information to do that, which is why I had to go back and look at momentum. All right? So that is page 515.